the country that dominates the 21st century is going to be the one with the lowest cost of energy. For a large share of US emissions, the least expensive approach is going to be an approach that is not putting out CO2. We can do it because we're going to change our energy systems. Well, that hasn't worked. We're still using fossil fuels for 80% or so of the world's energy. CO2 perturbation in the atmosphere, not each molecule, but the perturbation can last for centuries to millennia. Most of the poor low latitude countries don't have much air conditioning. What's that going to do? That's going to create tremendous number of environmental refugees. It's not just that people will starve. It's that people will put all their money into buying food, and that will collapse the global economy. The threat that some people worry about is an international food crisis. If you have enough electricity and it's inexpensive, you can build your economy, and then you can help take care of yourselves or something. It's like instead of giving fish to a fisherman, you give them the equipment so that they can catch fish. Electrifying everything saves energy and helps everybody. The question then is, can we get enough electricity to everybody? The planet is very sensitive to human changes. A lot of people say, oh, the climate's changed in the past.
Yeah,
it has changed in the past. It changed for a reason.
Hello, everybody. Welcome to another episode of Science Talk. I'm your host, Dr. Mohammed Ittifaq. In this episode, I'm absolutely thrilled to be joined by Dr. Mike MacCracken, one of the most respected voices in climate science with decades of experience in climate modeling, global change research, and international assessments. Dr. MacCracken has played a leading role in shaping our understanding of climate impacts and urgent need for action. From his work with the US Global Change Research Program, which was very successful, I heard program, but I don't know what is happening right now under the current administration with that program. And his contribution to the major UN and IPCC reports, he brings a wealth of experience and a clear science-driven perspective. So stay with us as we dive into his insights on the climate crisis, what the latest research tells us, and what are some of the solutions. Maybe they sound crazy at the moment, but we have to try something as we are dealing with this, one of the biggest crises humanity ever facing, and we should be focusing more on that right now. So, Dr. Mike, welcome to Science Talk.
Oh, well, thank you very much.
So, I hope I introduced you correctly, as you have almost 50 to 60 years of experience. I may have missed something, but I know you have undergrad and PhD from prestigious schools and you develop climate modeling. But I want you to start us with the question, when you started as a climate scientist, what did we know at the time and what do we know now? Has our understanding of the climate crisis changed or evolved over time?
Okay, so really started in climate studies in the mid 1960s in graduate school. In the mid 60s, there was first of all geological information that there had been ice age cycling over the past million years, but there was not an identified cause to that. It was not understood why it was happening, and what my dissertation was about was to construct a sort of what's now called an intermediate type of climate model and try and explore whether some of these hypotheses made sense. One in particular that was being proposed back then was that the opening of the Arctic Ocean would lead to the start of an ice age. That the reason we don't have lots of snow and ice buildup on the northern hemisphere continents is because there's not a good source of water. And if you have open water in the Arctic, that would be a lot of water that could evaporate. And so you'd have like lake effect storms, but it would be from the Arctic Ocean that would build up the ice. The ice would keep building up. The Arctic would stay open because without ice, it has a lower albedo, would absorb enough solar radiation. And you would sort of work through a cycle that way. And that was actually the prominent hypothesis because, and it was, I was prompted to get studied because there was a proposal, or proposals at the time to try and open the Arctic to get at its natural resources, its oil and other resources. And I was a graduate student one of the suggested approaches was to do nuclear weapons to try and melt the ice, a crazy idea, but Edward Teller, who was head of Livermore, sort of said, well, we don't even know what that would do to ice ages. So as a graduate student, why don't you look at it? So we now have a good, at the same time, the earliest high-level report was being sent to the president about the increasing CO₂ would lead to global warming and climate change. That CO₂ would change the climate and was a cause of possibly the ice ages or various changes, was one of the other hypotheses about what would happen. And so, there was concern about what warming would do using fossil fuels and what that would do to the climate. So since then, we've gained a great deal of understanding. The models are much better. We have much better geological understanding. We've come to a reasonable understanding of what causes the glacial cycles, the changes in the shape of the Earth's orbit. So we have a lot more information about how the world works. We've, I think, pretty much established, along with geological information, that climate change is not random. It's caused by particular forcings. There's a little bit of random stuff in it, El Nino and other kinds of things, but most of it is due to other forcings. Some are natural, like volcanic eruptions. Others can be human-induced, like clearing the land for agriculture. In fact, the first study about what might be changing the climate in the U.S. was by Thomas Jefferson, so a Virginian, like you're being at James Mason, that clearing the coastal plain of the U.S., the Atlantic coastal plain, taking down the trees, changed how the sea breeze came into the coast and how it affected the weather. So things change because of a cause. And so this putting all the CO₂ in atmosphere is changing the global energy balance and has the potential to change the climate. And right now, there's just no other way to explain what is happening without it being due to the changing atmospheric composition of the atmosphere.
So where that proposal came from, you said there was a proposal and the professor said to you as a graduate student, why don't you find out something? Because professor loved to have their graduate students to work on things like that. So where that proposal was coming from the federal government, or the professor has a grant, or where was the conversation happening about opening the Arctic?
Um, well, I mean, I should go back. If you go back to the 1870s, there were proposals to melt the Arctic and get at its resources. It wasn't clear how you would do that, of course. Then when nuclear weapons came along, the idea, well, maybe I can do that. It's not clear that that would work at all in any case. But Edward Teller, in addition to being very interested in nuclear weapons and talked about nuclear weapon design, was also very interested in what happens to the atmosphere. In fact, I think one of his early assignments on the Manhattan Project was to figure out and determine if a nuclear explosion would ignite the atmosphere and sort of destroy the world. But he was interested in the atmosphere. He was actually involved in the proposal and study that led to formation of the National Center for Atmospheric Research. And so he was curious about it. And so he founded a graduate program in applied science in the early 1960s. His belief was that universities were too stovepiped. They had chemistry department and physics department, biology or engineering or something. And that the interesting studies in the future about material science, about plasma physics, about geophysics, about other things would come at the interface of departments.
Mhm.
And so he basically founded a program where he sort of despaired of teaching physics. He was a chemist, actually, but despaired of teaching physics about engineering and chemistry because they were all interested in high energy physics going off. But decided if he brought chemists and mathematicians and engineers and others, got them to have a master's degree in physics, that then they would hopefully end up somewhere in between the fields. In plasma physics was one, and material science was another, and geophysics was another. And so I was very interested in the geophysics part. I was lucky to get awarded one of the early fellowships. And he said, well, why don't you look at this issue of figuring out what might happen if we melt the Arctic, and does that work? It turned out that the the scientist who had really done things at Livermore was a fellow named Chuck Leith. He was a mathematician from the University of California, Berkeley, out of Berkeley, and he became an early member of the Livermore lab projects, and he designed the first code to look at some aspects of a nuclear explosion. And what Livermore did, I mean, no university teaches how to create nuclear weapons. That is something you do. But the people in that field come from astrophysics or plasma physics or geophysics because we're dealing with the same equations. It's just at different pressures and temperatures and things. And so after he did this, he was sort of given a sabbatical. And he said, well, I've got the most powerful computer here in the world at Livermore at the time. I'm going to construct a global atmospheric GCM, general circulation model. Now, people talk about it being done at GFDL. That was a sort of hemispheric. It wasn't really global on what was. And so he constructed a global atmosphere. And Teller said, well, okay, you can't, I mean, it takes so much computer time, you can't do a full global model, but simplify it down to just latitude and altitude and put in thermodynamics. And I'd come out of engineering and a lot of thermodynamics, put in the surface and the thermodynamics, and then try and see, will the different stages of these glacial, of these glacial hypotheses, glacial interglacial hypotheses, will they work? The first one that was proposed actually was that you have ice ages because the sun is getting dimmer.
Mm.
And that was a prominent sort of geological proposal by geologists. But the trouble with that is if it gets colder, there's not enough warm water around to evaporate the moisture to make ice on all the ice on land. I mean, sea level went down 120 meters. 400 feet of ocean level around the world was piled up as ice on land. Okay,
Wow.
so if it's colder, you don't have enough evaporation going on to make that happen. So the next hypothesis was, oh, well, and a brighter sun will actually lead to an ice age. And you go, that seems crazy to a thermodynamicist. How does that work? Well, if you get more evaporation, the idea was you get more clouds. The clouds reflect away the solar radiation. So when the moisture comes out, it comes out as snow. But the trouble is when it's warmer, you get more convective, tall clouds. And what you need to get a lot of reflectivity is stratus clouds, flat clouds. And so you weren't going to get the reflection. You were going to get more of these convective kind of systems. So that didn't work. But what's interesting about the change in orbital elements, which I didn't look at the time, it was one of the hypotheses, but more complicated to look at, is what it does is changes the amount of solar radiation that is available in different seasons and different latitudes. So you build up ice if you have warm winters that allows a lot of evaporation and cool summers. You melt the ice and add the deglaciation when you have hot summers and cold winters. Cold winters don't allow for much snow, but if you have hot summers, and the orbital element would change the amount of summer solar radiation by like 7% or so. So it's a significant amount, and that's why the ice melted a lot. So the orbital element was a really interesting one about how it combined sort of the aspects of these first two hypotheses, but there were a number of others and stuff.
So, like just talking a little bit about nuclear, when I recently talked with another expert from England, Paul Dorfman, he claims or argues that nuclear is too late for the climate crisis, but there are some other people who believes that we do need nuclear to deal with energy, and we don't want to depend 100% on these renewables. So, in your experience, do you think that we do need nuclear to deal with the climate crisis?
Well, I guess the first thing I'd say about my attitude is that being pessimistic is just too depressing. So you
Yes.
have to have some hope about things. Um, so I mean, we really have to deal with it and we have to get going. The problem with nuclear right now, or at least in the US, is it's quite expensive and it takes a long time. And right now, by far the least cost energy is solar and wind. They're both becoming less expensive than natural gas. The problem in the US, and it's actually another little side project I'm involved in a bit, is that the solar's mostly located in the southwestern US, some of the southern Great Plains and stuff, and the wind is mostly in the Great Plains, and that's not where the demand is. And what you have to do is have a transmission system to move it from where it's available to where it can be used. We have that for natural gas and underground pipelines. We have it for coal by having rail lines that take coal to where it is and stuff. And the problem is that the high voltage transmission lines that we have now are alternating current. And those are only really effective out a few hundred miles. And so what is proposed by a fellow named Alexander McDonald, he's known as Sandy McDonald, is a supplementary transmission system for the US that is high voltage direct current. Because if you do this, you can move it across country for the same cost that you can move it just a few hundred miles on the existing system we have. And to do it, instead of putting it above ground, which everybody objects to above ground pipelines and you couldn't do it, you can bury high voltage direct current lines and you bury them along railroad rights of way or superhighway rights of way or river rights of way and other things. You bury it. It's a little bit expensive, more expensive,
of course.
but you can do it now.
Yeah.
And so you don't have to say, oh, I'm going to wait and wait and wait. So what President Biden's program was to decarbonize the electric grid that we have now. That's very nice, but we really have to decarbonize the whole economy in order to deal with it. And you can't do that with the existing grid. And so this fellow, Sandy McDonald, did some really interesting model simulations with micrometeorological conditions, very fine scale weather conditions over the US and the electric grid, and figured out how you could put in some of these high voltage direct current things, sort of a supplementary network. It doesn't replace the systems that come to people's homes or anything. It would just go to where the major substations are. It would be buried underground, which makes it more secure in a lot of reasons, from disasters, from solar storms, from other things. It would be modernized and stuff. When we've had major storms here, I live in Bethesda and in the East Coast, and I don't know, 10 years ago when the derecho hit, we went 5 days without electricity. Why was that? And it was sometimes blamed on local street trees, but that was not the issue. The main was the power lines from the Ohio River Valley power plants to Maryland were down because of the wind, and they had to get those up. Well, if I bury these lines, that's not going to be a problem. So one of the really important things to do to affect the transition is to promote the ability to move power around.
Yeah.
There's a very interesting thing to do. Go to Google Earth, look up Antelope Valley, California, go a little bit west of where it is scrub desert land. California, state of California, put in a power line from there, a major power transmission line, from there to a main connection of the grid. Cost them a few $1 billion to do. There is now something like $60 billion of private sector investment putting in solar farms there, because you can harvest solar radiation at about $40,000 or $50,000 per acre of solar system. And you don't have much manpower to do it, and it's going to be good for 20, 25 years or something that keeps going. It's a wonderful income source. And it's so good that now California is putting in a second transmission line to there, because there's all this private sector money sitting on the sides wanting to build systems, and it isn't being allowed in until you have a transmission grid to do it. And so the proposal is what the government needs to coordinate is build this transmission line. It would get paid for by user fees, not out of the tax income or something, but by user fees. People are transmitting it because the power needs change dramatically across the country over time. If there's a weather system can be completely cloudy and be 1,000 kilometers, 500 whatever miles in diameter. So solar doesn't really produce there, or it can be completely calm weather over that diameter. So nearby sources don't do any good if you have renewable there. You need to be able to transmit distances the size of a weather system. So if we get to doing smart things, some in China are starting to put in those lines. Some lines are being put in Europe. The US is lagging behind. It would enable, if we do it, to have the least expensive energy around. It's less than nuclear is, the big nuclear plants come in at 15 or 20 cents per kilowatt hour.
Yeah.
Solar is coming in at 2 cents a kilowatt hour.
Which is
Nobody's
significant
gonna,
cheaper. Yeah.
yeah, I
So,
mean,
so like you worked, under different presidents and different institutions and reports and committees. And the way you're describing early on, the way there are proposals and people doing things and there are funding available. But right now, the situation is very much different than back in the days. Now, even the funding related to climate and health and science and research has been cut off significantly. Even the institution you worked with previously. What do you think of this situation right now? Because 60 years of your career, that's a 15 different presidents in the US, not different, but like at least 15, different election cycles. And there's a lot of governments which come pro and anti-environment and pro and anti-climate and all that in terms of politics. But like, do you see that moving forward, since we have a COP and US was not there, some of the politicians went there, but not the US government as a representative. Do you think in the future, thinking about these ideas, it significantly actually create more problems for the US as it's already behind than China and European countries who are trying or doing different things related to climate? Does it push back too much? Like pull back, US is like behind on climate and doing research and being more innovative dealing with the crisis?
well, I mean, what business is going to do in the way we're set up is go for the least expensive way to do it. I mean, the country that dominates the 21st century is going to be the one with the lowest cost of energy.
Mhm.
The lowest cost energy is going to be solar and wind and some other renewables and stuff and a little bit of other things to fill in. It's not going to be fossil fuels.
Mhm.
Nobody's going to pay for that stuff. I mean, no businessman's going to want to pay for it, and you're not going to be able to compete in the world for it. So the president may be opposed to wind and solar energy or something like that, and that's unfortunate, but the private sector is going to push ahead. That is what some of us are trying to do, is facilitate getting this transportation system. If he would change his mind and say, I want to provide people the lowest cost electricity, then he would change and he would do this. He would build his transmission system. And so we have some ideas about how to try and get that started, trying to lay out the basis for doing it. Think about what the government leadership is and the important leaders in making our countries a country was President Lincoln, and there's etchings of him actually, right looking over the mapmaker's shoulder, trying to put in the railroad system. And then there's President Eisenhower, who sort of got the design and the requirements for the interstate highway system. Well, right now for electricity, what we have is the equivalent of the old highway system, the old US highway system that goes through every little town with
Mhm.
stoplights and everything, and you can't get anywhere. You can only
Yes,
go a few hundred miles. That's what we have for electricity all over
that's
this country. It
that's
is
true.
crazy. Okay, so what Sandy Alexander did, he had an op-ed in it in the Hill in January, was create an interstate highway system for electricity. That's essentially what is proposing to do, so that the people can put the solar things where they can be most efficiently done, and then the energy can be transmitted. That's what's done with, any product you have is the interstate highway system or sometimes the pipeline system and other things enables moving things around the country. And we have to do that for electricity if we're going to electrify our economy.
Yeah.
So that's going to make a difference. It's going to try and happen, with or without the president. I mean, it would be a great thing for
So yeah,
the
I think so.
president.
You're saying that we will be left with no choice other than electrifying and also going with this cheaper form of energy, and that is solar and wind right now. So one of the things that you also mentioned, phasing out from fossil fuel, that we can't rely on that and we can't continue doing that because it's not only polluting the environment, but it's also very expensive, and that generate a lot of emissions. And one of the things you talked about with Nick Breeze earlier in another interview a couple of months ago, that we have to cut emissions, but like, how do we do that? And why is it so difficult to cut emissions? Is it difficult?
Well, it's going to turn out that for a large share of U.S. emissions, the least expensive approach is going to be an approach that is not putting out CO2.
Yes.
So for the electricity you use for various purposes, for the electricity, I'm having electric vehicles. I mean, right now, one of the problems with electric vehicles is this idea that you have lithium batteries in there.
Yeah.
Okay, lithium's expensive and stuff like that. There's a whole host of companies working on alternative approaches, whether it's it's solid state batteries, which are sort of supercapacitors, and they can be made out of graphene and stuff. They're less expensive. They would make it so you could recharge your car in less time than right now you fill your gas tank. And you can have this longer mileage. So there are technical solutions out there. I mean, right now the challenge, I understand, having gone to a patent office meeting one time on it, was making these batteries so that they last as long as you want. They certainly work in the short term, but how long do they last? And so you have to have them glued together in the right way and stuff. But there's alternative approaches out there to do it if we're willing to move ahead, and they're going to be driven by to be taken up because of low cost. I mean, I have solar cells on my roof. I mean, it's a tremendous savings. My neighbors with their kids running in and outside in the summer will get air conditioning bills of $400 or something a month. I get a bill of $8.94 or something like that. I mean, people are going to do these things because they're economically driven to them, and they're offered that way. So if we would get on that pathway, get switched over to this other pathway, there's a great deal we can do. Is it enough? Getting back to some of your early comments, no. Decarbonizing is going to take time.
Mhm.
We're already as warm as we really want to be.
Yeah.
If you look over paleoclimate in the past Earth's history or something, as I said, at the last glacial maximum, sea level was down 120 meters, and all that ice was up on land. And for the next 120 centuries, after 20,000 years ago, sea level rose an average of 1 meter per year for 120 centuries. And the temperature over that time was rising about 1 degree C every 2,000 years, every 20 centuries. We rose 1 degree C in one century, probably going to be about 2 degrees this century. That's a huge amount of potential sea level rise. There's 60 meters or 200 feet or so of sea level equivalent of ice on land. I was just on a cruise with my wife, a vacation cruise in the Baltic Sea. Most of those countries have very low coastlines.
Mhm.
If Greenland wasn't a relic from the last ice age, that it was so tall that it kept cold and didn't have rain and melting on the surface, the coastlines of Northern Europe would be very different.
Yeah.
Um, and and uh, and stuff. So we really need to have Greenland there. There's not really a way of protecting and building levees across. So
So even like, we do all of these, go for cheaper energy sources and phase out from fossil fuel, but we already emit too much CO2 in the atmosphere, and that is going to stay there for hundreds of thousands of years. What do we do with that? Because that is going to continue increasing the temperature and warming the oceans and warming, the planet. So what do we do, the one we already emitted to the atmosphere?
Well, a number of us are at the point where we think it's going to be essential to try and exert a countering cooling influence. Nature does it by, for example, putting putting aerosols up into the stratosphere. That's the most talked about way to do it. If you can increase the reflection of the Earth by just 1%, that sort of offsets a fair amount of the warming we have had. It's sort of increasing the need at about 0.2%, so small amount per decade if we continue with the present emissions. And so the question is, can you shave off that maximum warming as we're getting this conversion? A number of us are saying we really want to do that because there's some potential tipping points that could really take us to irreversible conditions.
Yes.
For example, if it's warm enough to melt the permafrost and put out CO2 and methane from all that peat, that just sort of makes it almost impossible to take out, to do things. Or it could change ocean circulations and it can melt ice sheets and things. So you really want to keep the peak warming down. And so can you use this volcanic aerosol to do it? Now, the question you raised about how long it lasts is really important because CO2 perturbation in the atmosphere, not each molecule, but the perturbation can last for centuries to millennia. But there was just a wonderful press release out of UC Berkeley about a material that can help scrub CO2 out of the atmosphere by cleverly catching it in these little particles and everything. And then you take those particles, put over in this other chamber, warm it up just a little bit. The CO2 comes off and you capture the CO2 and then you have to figure out how to put it underground or under the ocean or somewhere. But so there may be things over time that develop to pull that legacy of CO2 we've emitted back out of the atmosphere and stuff. But in the meantime, we want to keep the atmosphere from getting too warm to get irreversible. I mean, if you start getting sea level rise of 1 meter per century, that's a lot, and it could well go up to several meters per century at the rate of warming we're having. Indonesia is already moving its capital because it's at low elevation. Most major urban areas in the world are at sea level or near that. And it's going to be very hard to adapt to that, to build
Yeah.
levees to protect things. So a number of us are sort of at the point that we've got to be considering it. There are some people saying, oh, just do more research.
Yeah.
Our view is, look, what we need to do is get started and then improve the approach over time. It's going to be, we think it's going to be well less risky than sort of going forward without doing that. There are risks. We're not saying it's, harmless, but it's a relative risk evaluation, and we're trying to get that discussion on the table.
So recently, I talked with another person who is an entrepreneur and MIT graduate physicist, Peter Fikowski. He talks a lot about climate restoration. He mentioned two methods, is like direct air capture or iron dust. He's like that's another way to do things, and he also mentioned along the lines that maybe we cut down the oldest trees and dump them in the ocean, 1,000 meters down in the ocean, and that would sink, the carbon and other things. So he also talked about like those methods, and he said like we can do it and it's possible. But I don't hear much of the conversations about that because I think maybe I don't know if it's like controversial to say, but like I think we are too much locked into the temperature like increase and like less focusing on maybe other issues. But so like you saying that we have to try these things, but like do we have time for these things and have we tried any intervention so far, or we just still talking about different scenarios and how they're gonna look like, or is there any actively, kind of installed intervention or mitigation strategy or something which is actively working out there or has failed, or like what is going on with that, or we're just still talking about it?
Well, we've had some countering cooling influences out there over time, not advertently, but inadvertently. The SO2 that comes out from coal-fired power plants, for example, If you go back to the mid 20th century or the early 20th century, when there were no controls for SO2, it was going up in the atmosphere. It formed a sulfate haze. So if you've flown across the Atlantic back then, you saw this sort of hazy atmosphere. It was reflecting solar. Um, and if you look at what was happening with respect to the temperature increase in the mid 20th century, it had sort of leveled out. And that was because the cooling influence was growing because they took the SO2. The first solution to SO2 was to put it out of tall stacks instead of emitting it at the ground. If you emitted it at the ground, it would react with vegetation, and its average lifetime in the atmosphere was a day or two. And if you go up around the Sudbury, where the Sudbury nickel thing was, there was no vegetation for 20 or 50 kilometers out or something like that. So the solution was build a tall stack and just spread it out in the atmosphere. That left it in the atmosphere a longer time, a week or two, let it turn to the more sulfate form. It formed its whitish haze, kept the temperature down. And then we started cleaning it up because you didn't want acid precipitation and everything on land. And so then the CO2 effect and the warming effect took over. And then recently, just in the last several years, they've taken the SO2 out of the bunker fuel that is powering ships. And so the amount of sulfate in the atmosphere went down. And that seemed to lead to fewer clouds because these particles can create brighter clouds and things. Lead to lower clouds, and the warming is accelerated. So we pretty much know that we can do an effect. Those were all sort of done for other reasons. Putting the SO2 and sulfate in the stratosphere is important because in the lower atmosphere, if you put it in and try and have that effect, it only is there a week or two. And so you have to put a lot in. And then when it comes out, it's sort of acid precipitation affects people's health and other things. But in the stratosphere, the lifetime is a year or two. So you need 1/50th or so of the amount. And so it's a much smaller amount, and it's much more widely spread out from the industrial areas so that you don't run into the health effects and stuff. So it's a doable thing. Um, Direct air capture has turned out to be expensive. This new Berkeley approach might be an interesting one that brings it down by a very clever sort of catalyst of doing it. Um, Cutting up, I mean, the cutting trees and sinking them, the present more cost-effective approaches that are proposed are gather up waste biomass from agriculture, from lumber and timbering and stuff like that, and turn that into charcoal and put that in the soils. And that in agriculture lands tends to improve the soils. It basically holds more moisture, so allows more production. So while warming climate is heating the soils and leading to more evaporation, the more biochar that you put in the soils helps hold the moisture, and that helps it for the plants. So it's sort of a productive use. You get some financial benefit from the energy you get derived. You get it from what the increased agricultural production, and then maybe you get it because it's a carbon credit or something like that. So there are proposals to do that on land. There's proposals to do that from the ocean, to grow biomass in the ocean and do that.
So let's say for the worst case scenario, hypothetically, we don't do these things and we don't test these interventions at a larger scale, and on the other hand we continue emitting more CO2 in the atmosphere. What would be our last resort in that case? By 2050, for example, in 25 years, if we see the temperature is 3 degree Celsius or 2.5, in that case, what would you say our last resort would be?
Well, I guess I'd say we're at the last resort right now. I mean, what this solar intervention is the last resort.
Mm.
People have, if you go back to that 1965 report from the President Science Advisory Council, they mention it may be necessary. That was, what, 60 years ago. They're saying that it might be necessary, so it was in the book. But there's been there was a view, well, we can do it because we're going to change our energy systems.
Mhm.
Well, that hasn't worked. We're still using fossil fuels for
Yeah, we
80%
are.
or so of the world's energy. Then the idea is, oh, well, we can adapt to it or something like that.
Yeah.
Well, no, there are some things you can adapt to, but all this increasing extreme weather, the rising sea level, The very hot heat index that is occurring in heat waves in low latitudes, which is going to be life-threatening unless you have air conditioning, and most of the poor low latitude countries don't have much air conditioning. What's that going to do? That's going to create tremendous number of environmental refugees. We think we have a problem now in some countries. It'll
Yes,
be
like Bangladesh.
1,000 times greater than we have now as people to survive try and move out of these countries. Um, so we've got to do it now. We're basically at that point where we have to be using this last resort now. And the argument is only exactly when you start sort of doing it, because countries just aren't getting their emissions down as everybody had hoped would happen.
Yeah, and I think the recent Guardian report says that there has been already 250 million people displaced due to extreme weather conditions over the last few years. But one of the things a lot of people talk about, like when it comes to CO2 emissions in the atmosphere, that we have to take them down to the pre-industrial level. Is it realistic? Is it doable? Is it possible that we go back to the pre-industrial level emissions?
Um, well, no, for most things, as far as temperature. I mean, the agriculture systems, the farmers, the buildings, our structures are sort of adapted to the mid to late 20th century. And so that's probably what you'd go back to maybe 350 parts per million from 420 or to a little bit lower than that. Now, there is one exception. There's been an interesting paper, and that is if you get the ice, if Antarctica starts really melting and Greenland starts really melting, um, it's hard to cool off that ice. It may be that for a short time you want to go back to lower than this mid 20th century and to sort of have early 20th century kind of conditions and see if you can get these major ice masses to stay frozen. Because if they melt, and thaw and add to sea level, that's going to be huge. And that isn't very well recognized. There was a big to-do, it turns out, over the last IPCC assessments in the sea level chapter, because the original drafts of the authors said, oh, we're highly confident that sea level will be less than a meter rise by 2100. And a number of us said, how could you be 95% confident, which is what they were sort of saying, by that? That's just crazy to do it the way these ice streams are starting to thaw and get going. And it turned out because they had been using sort of a very scientifically cautious approach.
Mhm.
Scientists are cautious. We're building this pyramid of knowledge. We don't want any cracks. And they said, we don't know how to represent how fast ice streams can flow and calve into the ocean and add to sea level. So we left that term off.
Mm.
And we said, you can't leave that term off. It's probably going to become the most important term. You have to do something. Even if it's uncertain, you have to say it. And so if you look at the final version, it has this little sort of dashed line that goes up to, well, it could be 3 meters or something like that. And that's only in 2100. I mean, because once you get it going, it's going to continue out because
Yes.
the more it melts, the lower it is, the lower it is, the warmer it is. We should really, if you're thinking about, building a new community at sea level or something like that, you really need to be thinking that it's going to be going up or something. Don't build important facilities like major hospitals on barrier islands. I mean, there are a whole bunch of things that you would think about reducing societal risk,
So,
and that has to be done. So.
yeah. So, in your experience and overall assessments, what is something which keep you up at the night? Is it more of a sea level rise, or like melting glaciers, or like increasing more droughts, or more stronger hurricanes? What is something which keep you up at the night, thinking of when we think about these extreme weather events?
Well, since I'm as I like to say, I'm now 1,002 months old, if you want to figure out what that means. I've got some 100 months or whatever, to go, 100 or two. Um, so it's not so much my personal things, but it's these increasing extreme weather events that keep happening and everything. And what are people going to do about it? I mean, there's a a trend of over a century and more precipitation occurring in drenching rainfall events. So you have less of these moderate rains. So the poor farmers, instead of getting a little bit of rain through the summer and a bunch of events, they're getting these big events that cause most of the water then will run off. It'll erode the soils, and so the threat that some people worry about is a international food crisis.
Mm.
We don't have much international food stocks. We're right at the rim. We've seen examples of what happens when the supplies from one country are cut off and what that does, whether it's what happened in a drought in Syria that led to Arab Spring or contributed to Arab Spring, whether it's Ukraine and it was shut off by war, whether it's Russia, which has had some seasonal problems that have led to low things and they stopped exporting grain. For most international food commodities, the big grains and stuff, there's only like 5 countries in the world that contribute like 90 to 90% of those exports. And it's imported by 100 countries
Mm.
that depend on it for food.
Yeah.
Okay, so we've had examples of what happens when there's shortages in just one of those 5 regions for various crops. And prices go up. And it turns out the food price is not, food is not a very elastic on that or something like that. People have to eat to survive.
Yeah, absolutely.
They might be able to change from one to another, but they have to eat to survive. And so what's going to happen when just randomly we get problems in 2 of those areas?
Mm.
What if that lasts for 2 years? What if we have a food crisis in there? It's not just that people will starve, it's that people will put all their money into buying food, and that will
Absolutely.
collapse the global economy. And if you think the mortgage crisis collapsed the economy some 15 years ago, this will cause a much bigger collapse of the global economy. And so that's something that could happen just from the extreme events and
Yeah,
stuff.
and I think Iran is facing right now extreme drought in the last 6 consecutive years, and now they're like thinking about, shutting off water for 3 hours or like 10 hours and within 24 hours or moving whole Tehran population 10 million somewhere else.
Exactly. I mean, there are going to be very vulnerable
Yeah.
countries in this, and what's going to happen is people want to survive, and they're going to try and do something. They're going to try and move somewhere. They're going to create problems, stir war, whatever is going to
Yeah,
happen. There's
absolutely.
just
Whatever it takes them
all
to
kinds
survive.
of
Yeah.
disastrous consequences that could come, and the world we knew that was sort of relatively, peaceful and stable in the latter part of the 20th century. In many ways, we're going to lose that. I mean, I was involved in a lot of U.S.-Soviet relations in the 1980s, and think back and so those were the good old days. I mean, when we had that, we had relations. We were trying to do things in many ways. We're trying to do things together and try
Together. Yeah.
and help. And we might have been opposed, and there were military forces and all that stuff, but there's a lot of cooperation going on in space and this and exchanges and a whole host of other things. That's breaking down, and it's just climate's just exacerbating a lot of the problems.
Absolutely. So one of the things you said that being pessimistic or being depressed is not good, and being hopeful is something we can think about solutions and things. So in the opposite, the question I earlier asked, what keep you up at night? What keep you a good night's sleep when you think about some of the solutions? And do you think being on the hopeful side that maybe in the next 2-3 decades we will come up with some good solutions to counter some of it, if not all of it, from climate crisis point of view.
Well, electrifying everything saves energy and helps everybody. The question then is, can we get enough electricity to everybody? So that's going to be the challenge and the solution. Right now the Conference of the Parties gets arguing over the loss and damage
Yes.
issue. The idea that 1 billion people in the developed world are going to be able to give up enough resources and be willing to give up enough resources to take care of the damages that are going to occur in the I don't know, 5, 6, 7 billion people in the developing world. It's hard to know how to count China, but give up enough resources for all those other people to take care of their damage. I don't see how it's going to happen.
Yeah.
What I've got to do is help make those countries in good enough shape that they can help take care of themselves. And if they could, if providing electricity to them, I mean, you look at Africa, it has plenty of potential for solar radiation. If you could distribute it around the continent, every country had plenty of electricity, it certainly has potential workers in those fields, and it could become economically well off. And that's true for most countries around the world. If you have enough electricity and it's inexpensive, you can build your economy and then you can help take care of yourselves or something. It's like instead of, giving fish to a fisherman, you give them the equipment so that they can catch fish.
Yeah. That's more sustainable. Yeah.
Yeah, yeah. And so we've got to ensure basically that the sustainable development goals that are proposed by the UN remain viable. And the trouble is with climate change, they aren't viable. I mean, it becomes just harder and harder to try and make them have an effect. So we have to get climate change, under control, and that's why a number of us, talk about the solar radiation management and try and, climate intervention to try and limit the situation from getting worse while we do these other things to get the situation under control.
Yeah.
That's a whole host of things to try and arrange. It's hard to do internationally, but it's really important to get working at it.
Yeah. So one last question before I let you go is I ask everybody is what is something which is still missing from the climate conversation and we should be spending more time talking about it?
Well, for the Conference of the Parties, it's talking about this issue of climate intervention at all.
Yeah.
I mean, the group of us talking about climate interventions is pretty small. I mean, there's very little, relatively little funding. A couple of countries are starting to put up some money for it, but it's basically the last approach in the bucket. And and what people I think don't sort of understand is as we head further, 1 degree Celsius doesn't sound like much, or 1.5 degrees Celsius. I mean, people move from Syracuse, New York to Phoenix, Arizona or something, but ecosystems can't move. Not all our agricultural production can move. Things can't move. And so these seemingly small changes, I mean, 6 degrees Celsius, so 4 times where we are now, was 120 meters of sea level up on land as ice or something. You go, the planet is very sensitive to human changes. A lot of people say, oh, the climate's changed in the past.
Yeah.
Yeah, it has changed in the past. It changed for a reason.
Yeah.
And we're affecting that reason right now. We're doing the same thing. And so the planet's going to change by a great deal. And I mean, it's absolutely amazing how much all the orbital elements does is redistribute solar radiation, the same amount of energy coming in by latitude and season, and it causes an ice age or not. You go, whoa. I mean, that's in the IPCC scheme of radiative forcing, that would sort of be zero as opposed to a change because it's just moving things around. And IPCC talks about the globe as a whole. So, yeah, getting better context of how sensitive the Earth's climate is really important.
Thank you so much. We have to leave it there. Dr. Mike, thank you so much for coming on Science Talk. It was a pleasure talking to you.